Hi, welcome to your lesson on quadratic inequalities. To begin, we should remind ourselves what inequalities are. They are these symbols here. These symbols are sometimes used instead of an equal sign. This is the less than symbol. This is the greater than symbol. Here is less than or equal to, and greater than or equal to. Let's compare quadratics using equations and inequalities. So here is a quadratic equation. We can see the equal sign. And here is a quadratic inequality. We can see the inequality symbol. Let's look at this one first. If somebody asked you to solve this quadratic equation, we would often begin by setting y equal to 0. And then we can maybe factor this. Okay, it factors. Once we have the two factors, we can set each one equal to 0 in order to get two solutions of x equals -1 and x equals 5. So notice when we have an equation, we end up with solutions. This is because these solutions represent where the parabola intersects the line y equals 0. So notice at this step here, we have this parabola, and we're saying it equals to 0. So it's basically saying this parabola, when is this parabola equal to a line at y equals 0? So what that means is, here's our parabola, here's the line y equals 0, and again, in this statement here, we're saying when is this parabola equal to y equals 0? Well, it's equal to y equals 0 right here and right here, and those are our two solutions, which are our x-intercepts. Now let's look at an inequality. So we have this one. We can follow the similar steps. Set y equal to 0 if we're trying to solve this inequality. Then we can factor this, the same as we had here, except we now have this inequality symbol still. So in this case, we don't jump to these solutions. We consider the graph to see what the solution set is. So take a look. It goes like this. So this solution represents where the entire parabola, this entire parabola, is less than or below the line y equals 0. So here we have this parabola, but this time instead of being equal to the line y equals 0, it's less than the line y equals 0. So graphically, what that means is here we have this parabola, and we're saying when is that parabola below the line y equals 0, because this means less than. So it is less than the line y equals 0 right here. So what x values does that represent? So it happens, so here again, this is when the parabola is less than the line y equals 0, and this occurs when x is between -1 and 5. So instead of giving two solutions, we say there's a solution set, because there's a set of numbers that works, and it occurs when x is between -1 and 5. So that means x is greater than -1 but less than 5. So it basically is saying from 1 to 5, all those x values represent when this parabola is below the line y equals 0. So pause this slide, really let this idea, just absorb this idea carefully, because understanding it graphically is the key to working with these problems. Okay, let's take some notes. Let's try some more like this. So first one, let's solve this quadratic inequality. First step, set y equal to 0. Next step, if you can factor it. And yes, we can. There it is. So now we can see from the factored form, even though this is an inequality, if this was an equal sign, we could solve this and get two x values, the two x-intercepts. They would be 2 and 4, right? So now, this solution represents where the entire parabola is less than the line y equals 0. So the entire parabola right here is below, less than this line. Okay. So graphically, we can also think about it this way. It's important to remember concavity. So is this parabola concave up or down when you look at this? Well, we know it can either be like that or like that. And we know in this case it's concave up because a is greater than 0. So the a value is greater than 0, so it looks like this. And that's important to consider when we do these ones. Okay, so when is this parabola less than the line y equals 0? Okay, the parabola is below y equals 0 from 2 to 4. Again, those were our solutions. We can see the solutions here from 2 to 4. And since this parabola is concave up, it is below the line y equals 0 from here to here. So the solution set in this case is x values between 2 and 4. So from here to here, those x values, that's when the parabola is below the line y equals 0. And that only happened because it's concave up. If it was concave down, it would be different answer. Alright, let's try this one. Solve the quadratic inequality. So we have this one. Just like normal quadratic equations, we want to get everything on one side and 0 on the other side. So let's move the x and the 3 over there. Okay, so then we subtracted x and added 3 to get this. This is now greater than or equal to 0. So this cannot be factored. So in this case, we can use quadratic formula to solve this, because we need the x-intercepts. We always need the x-intercepts to figure out then when it's below or above. So solve it using quadratic formula. Here are two solutions, one plus or minus that. Alright, that can be given as decimal values. So we'll see those in just a moment. But this solution represents where the entire parabola is greater than or equal to, see the entire parabola greater than or equal to the line y equals 0 right here. Okay, so graphing the parabola. Okay, first of all, again, is it concave up or concave down? Look at the a value. Well, the parabola can either be this one or this one, and notice these two solutions here are given here, negative 0.781 and 1.281. Okay, this parabola is concave up because the a value is greater than 0, right? A value is positive, so it's concave up. So now when you're looking at when is this parabola greater than the line y equals 0, so when is this parabola greater than the line y equals 0? Well, it's above the line y equals 0 over here and over here. So what is our solution set? So the parabola is above y equals 0 when x is less than this value, less than negative 7.1, and also when x is greater than 1.2. So it's this zone and this zone. It's not the in-between zone, it's now here and here. So the solution set, therefore, is x values less than or equal to that number here, and x values greater than or equal to this number here. So again, these values and these values of x. So these ones and these ones, but not these ones in between. Okay, again, pause and really think about it. This is important to understand the graphs and how they match the answers. Okay, let's try another one. So it says, in this case, we're going to be allowed to use our calculator. So rather than trying it algebraically like we did, you can go straight to your calculator after creating your quadratics. So let's take a look at A. In A, again, move everything to one side and get 0. So those two parts moved over there, and we have this greater than or equals 0. So now, rather than trying to use quadratic formula to solve this, or factoring, I don't think it factors, so we can use our calculator. So think of it this way. We can graph this parabola, so there it is, so graph that on your calculator. And now on your calculator, you can figure out the two x-intercepts by finding the zeros. So find the two zeros, what are they? And then you're looking for when is this parabola greater than or equal to 0. So when is this parabola above the line y equals 0? Well, over here and over here, right? Okay, so the solution represents when this parabola is greater than or equal to this line, and that means right there and right there. So what are our solutions? So you can find the x-intercepts again on your calculator, hopefully you found those, and then you can state your solution set. So when x is less than 0.719, which is these values, and when x is greater than 2.78, which is from here onwards, so it's those values. Again, consider the solution carefully. Now let's try B. Now B, rather than moving everything to one side, let's look at it in this form, because you don't have to move things around. When you're using your calculator, we can just consider we have this parabola and we have this line. We don't always have to make 0. If we make this 0, it's just saying the line y equals 0. But here we also have the equation of a line. So this one, rather than rearranging this inequality, think of it this way. When is this parabola, this one here, less than or below, less than right here, below the line 2x minus 2? So when is this parabola below this line? How about graphing them both on one? Graph them together and see what they look like. And find the intercepts between the two actually. So you're going to graph this parabola, and for your y2 you're going to enter this line, graph them together, and then find where they intersect. Okay, this is what your graph should look like. and hopefully you found this intersection point and this one here. And now the question is, when is this parabola below this line? So when is this blue parabola below the red line? Well, that occurs right here. So that means from this x value to this x value, the parabola is below the red line. So our solutions, graph those two, so I'm just reminding you, graph those two, and then the solution set, again, if you found those intersection points, tells us that x values must be between 0.242 and the other point is 2.76, and we see x is between those values because that's when the parabola is below, right? For the x values from there to there, those x values is when the parabola is below. Great, okay, you're ready to look at one like this. So we're going to look at the ones where we have an equation, there's a k in there in our standard form quadratic, and we want to see when does this one have no x-intercepts. If this one has no x-intercepts, that means it has no solutions. And a quadratic that has no solutions occurs when the discriminant is negative. So set up a discriminant for this that shows that the discriminant is negative. Okay, it will look like this. The discriminant is less than 0. Put in the values here. B value goes in here, and then 4 times A value times C. We end up with this. So notice in this kind of discriminant problem, we end up with an equation like this that has an inequality. So we didn't deal with those yet in our discriminant problems, but now we see them here. So we have this, it must be less than 0. Think of it just like we did the problems a moment ago. We have a parabola and it's less than or below the line y equals 0. So when is it below the y-axis? Oh, sorry, this is the x-axis, right? Alright, so that can be factored into this. Or if you had an equals sign here and solve this, you can move the 36 over and find out that k has two answers, positive 6 and negative 6. So now we know those are our intercepts for the x-axis. And graphing it, we have this parabola, and there's the two values, negative 6 and 6. And notice that those, now we're looking for the parabola that is, this parabola is below 0. So the parabola is below right here, and that means our solution set is from negative 6 to 6. So k values from negative 6 to 6, and then the parabola is below. So in this case, we solve for k, not x, right? We were solving this equation here. So now we know when k is any number between negative 6 and 6. So if k was any number between negative 6 and 6, this quadratic here would have no solutions. Okay, so don't confuse this quadratic with this one here. This graph is for this one when we're solving k, but the graph of this one would be a very different graph, and that graph again would have no solutions when k values are between negative 6 and 6. Okay, try this one. Okay, to have no real roots means that the discriminant is less than 0. No real roots means no solutions. That means we have a negative discriminant. So here's a discriminant for this one. 6m squared here, minus 4ac is here, less than 0. That can factor like this, which allows you to get two solutions for m. And they are m equals 0 and m equals 1/9 from here. So that's our two solutions. And now we're looking for when is this parabola below 0? First of all, is this concave up or down? Well, it's concave up parabola because a is positive. And then we see our two solutions here, 0 and 1/9. And we want to know when is that parabola less than or below this line y equals 0. So it's less than it here. That means between 0 and 1/9. So solution set, m values between 0 and 1/9. So again, if you put those values into this equation, you can take any m value between 0 and 1/9, put it in here, and it'll give you a parabola with no solutions. Okay, try this one here. Two distinct real roots means two solutions. Okay, when a quadratic has two solutions, the discriminant is positive, so greater than 0. Discriminant here, greater than 0. b squared minus 4ac greater than 0. Solving that further, you get this. Combine those, you get this. And finally, you get to this point here when you factor that. That gives us two solutions. They are k equals 0 and k equals 1/4. Now this parabola again is concave up There's our solutions, and we want to know when it's greater than 0, so there is our solution set right there. It's greater here and here.